video will deal with examples more like 4.8. There's one topic about bearing angles that we'll talk about on Monday, and it'll be in Monday's video, just because there's already been enough information given in the last two videos. So these are still real-world problems. They're just a little bit more complicated in their detail. So from the top of a 100-foot tall hall, a man observes a car moving toward the building. So we have a building and a man hanging out up here. He's looking down. There's a car moving towards the building. Okay, can't draw a car, sorry. What happens is the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation. How far did the car travel? So when the man first looks at the car, you have this right triangle, and the angle of depression is 22 degrees. Then the car moves a little bit, and the man looks again, say it moved here, and now this angle is 46 degrees. Remember, the building's 100 feet tall, and we want to know how far did the car travel. And if you think about these, the smaller the angle, the smaller the car is away. Think about when you're walking up to a building, and as you get closer, you typically look up and up to actually see the building. So the angle will get steeper as you get closer to the building. So if you notice, hopefully, these are kind of two triangles inside of each other, which is one of the real-world examples that you come across. So we have one little triangle that is 146, and we have this unknown measurement here. I'm just going to let that be represented by A. Then we have the other triangle where I still have 100 here, and I have 22, but this is the distance from here to the first position of the car, which if I put those together is A plus X, or I'm just going to let that be represented by B because I don't want to make it any more complicated than it has to be, but we do know that it is A plus X. I'll let this be B. So what I can do is find these side lengths of these triangles individually and then use them to find X. Because if this whole side are these two put together, then to find X, all I need to do is subtract those two. So, like in previous examples and a lot of times, tangent is a trig function I would use. So the tangent of 46 is 100 over A. In this case, that would make A 96.57. Then, same thing, tangent of 22 is 100 over B, and that would make B 247.57. When I subtract these two, because B minus A would give me my X value, that tells me the total distance that the car traveled is 150.94 feet, or about 151 feet. So this one, trying to find the distance the car traveled. In the last example, we have a penguin, helium-filled penguin, so like a float for a parade route. And it is high in the sky. It has two cables attached to it underneath the penguin at angles of 48 and 40 to the ground. And they're in the same place as a perpendicular line from the penguin. So what that just tells us is that this does form a right triangle. So if, I don't know, penguin, wings, I don't know. Penguin, close enough, he's got a little white belly. He's up in the air and has two cables that are attached to him. And it's the same place as the perpendicular, so it's a right triangle. Remember we said the smaller angle goes outside, bigger angle goes inside. And the difference to this one is we're told that the cables are 10 feet apart from each other. And I want to know how high it is above the ground. So we still are dealing with two triangles within each other, except for I don't have this common height that I can use to then find the difference between the cables. But I still can kind of set it up the same way. I have one triangle. X is my height. 48 is my angle. I don't know this, so I'm going to let it be Y. So in this case, the tangent of 48 is X over Y. Then in my other triangle, I have x, I have 40, and then this would be y plus 10. And like before, you can let it be another letter, z or whatever alphabet if you want, but we're going to actually have to find it and kind of go back and forth, so it might be a little bit easier to keep it in y plus 10 this time. So then on this one, when I do the tangent of 40, I get x over y plus 10. And what I notice is that x is a common variable in both equations. So the kind of trick to the trade of this one is if I can solve them both for x, then I can set them equal to each other because they both equal x. Then at that point they should equal each other. So what I mean by that is here, x would equal y times the tangent of 48. And here, x would equal y plus 10 times the tangent of 40. And I put parentheses around that because whenever you get x by itself, you multiply by the whole thing. And you don't want to accidentally think it's y plus just a 10 times the tangent of 40. That's another common mistake that happens with trig problems is your use of parentheses. So be very, very careful with use of parentheses. So now I have my two equations both equal to x. So I can set them equal to each other. Y tangent of 48 equals y plus 10 times the tangent of 40. We should distribute and get rid of the parentheses. Then I notice I have a y in two of them. And if you remember kind of the little trick of the trade whenever we were solving for inverses of rational equations, if you get the y's on the same side, then we can factor out that y and solve for it. So the way to do that is to subtract it. I factor it out because it's the greatest common factor. Then I can just divide it away because now it's just y times this. So y is going to equal to 10 times the tangent of 40 divided by tangent of 48 minus tangent of 40. And this is very tricky to type in the calculator. Remember, we have a couple of tricks in our sleeve. We can use alpha y equals and do the fraction and type it in. And look, mine's negative. You might know what I did. I forgot to put my calculator in degree mode. So that's a key indicator I did something wrong. So if I do it again, you see it's 30.94. 904, excuse me. If you forget the alpha y equals to do your numerator over denominator, and you type it straight out, the key here is going to be you're dividing by this subtraction, not just by the tangent of 48. So you're going to put that in parentheses and then be very careful that you close it again. So there's like a double parentheses there, and it'll still give you the same answer. So be careful on either writing this parentheses in the denominator or using that alpha y equals. All right, so then this gives me y, which is not what I'm looking for. I'm looking for x. So then I have two expressions that I can use to find it. This is the easier of the two. So if x equals y times the tangent of 48, then that means x equals 30.90 tangent of 48, which means this little penguin is only 34.32 feet in the air. Kind of crazy how that works. This is the end of what we're going to do for 4.8 right now. These are the practice problems of what we did on Friday. So I would go through those. I believe these talk about the bearing. So if you see that word, just skip it for now. But after Monday, you should be able to do 21 to 25. And good luck, and let me know if you have any questions.